Welcome to the podcast, Forecasting Tomorrow, episode number 2.
Yes, let's rock and roll.
Are you excited?
Very much. I think it was fun the last time, so hopefully it will be this time as well.
Hopefully.
I have at least prepared something I think is funny.
Oh,
well,
no.
Not funny,
Oh no, I know your humor.
Yeah.
Okay, but before we get into that,
Yeah.
I want to start out with something quite amazing, actually.
Nice.
So we all know that trees and wood has a significant role in terms of, moving into a more sustainable future.
It is one of the most important natural resources.
Exactly, and we've all, tried paper straws and paper cups, and we all know how terrible that is.
Yes.
But the good thing is, it removes plastics.
Yeah.
But there's also other kinds of, manufacturing ways for consumer products that we use every day, where the big sort of gain is from, reducing the energy consumption with producing the item.
Yeah,
right?
Makes sense.
So I have an item which, at least when I saw it, was, is that really possible? So I'll get to it right now. So
But maybe I'm sorry I interrupt you, but I think it's a nice thing to talk about because, as you probably also hear all the time, is with the electrical cars. Yeah. But how about manufacturing? That's way worse than everything else.
Yeah.
But I don't know if it is. I don't believe it is, but
I think
that's always an argument. So let's.
I would assume it's easier, to be honest.
Yeah,
But
agree.
let's take that in another
Yeah.
episode.
Yeah.
So what I want to talk about is transparent wood
Transparent wood.
for glass in windows.
Whoa.
Yep.
I didn't know about that.
So there is a laboratory in the USDA Forest Service Forest Product Laboratory, and they've actually created a transparent wood in the form of low density balsa tree,
Okay.
where it's treated at room temperature in a oxidizing bath that bleaches it to almost visibility, and then it's penetrated with some synthetic polymer called polyvinyl alcohol (PVA).
Okay.
Yeah, don't laugh. Which creates a product that is virtually transparent.
Okay, that
And
sounds so out there.
Yeah,
But
exactly.
Yeah.
And the good thing about this is it's actually more, it can withstand much stronger impact than glass.
Yeah, that would be my question. Exactly. What is like the strength of it? And
It's good.
Yeah.
And even better, when it's, let's say, exposed to forces, it bends or splinters instead of, shattering.
yeah.
And the good thing about this is also 5 times more efficient in terms of, what's that called? Thermally efficient than glass.
5
So it's-
times.
Yeah, so it's cutting down energy costs as well.
Yeah, so you actually maybe only need 1 layer instead of these 2 to 3 layers we use in Denmark now.
Maybe.
Yeah.
And the good thing is that it's also quite easy for manufacturing, because you could already use the normal sort of manufacturing setup that you have for producing windows and so on.
Oh.
So it seems like a win-win-win-win-win. And at least I think it's quite funny that you can actually see through glass and see through a wood. And it's also it ends really nice, this article. With all these potential benefits for consumers, manufacturing, and the environment, the case for transparent couldn't be clearer.
Nice. Nice.
Ding. Yeah.
I actually have a little of an anecdote from my career in robotics.
Oh, yeah.
Because when I was at the university, we did a research project on not creating glass or anything like that, but using a robot to install glass.
I remember.
And the reason for that was that, typically office buildings and so on was built in drywall, but it was much cheaper to use glass. So that's why so many office buildings that was built from like the 2000 and onwards were built in glass, because the manufacturing of glass was much cheaper. and it's so easy to put up one. The only thing is that it's extremely heavy.
Yeah.
So that was what the robot was for. That was for lifting the heavy stuff and also doing some kinematic movements. There was also talk about full autonomy, but let's keep that to another talk. Yeah. But the idea is that glass was much cheaper to build with. So it's nice to see that we actually, because one of the downsides of glass is that it needs a humongous amount of energy to create.
Yeah.
Because you need to heat it up that much.
Yeah. And it's heavy, like.
Yeah, it's really heavy. Yeah. Like a glass panel, like 180 times 60 is like 100 kilos or something like that. Yeah. 80 kilos.
And this is lighter and more, or it takes up less energy to produce.
Yeah, nice.
Do you actually know that, I can't remember where I heard that, but a lot of these investment companies, when they invest in new buildings, they have actually shifted away from glass now because it's, I mean, the impact on the environment is too great on these types of buildings. So they're now shifting away from it.
Yeah, but also thinking about it, there's nothing I hate more than sitting in like a glass cage. It's like you're like an animal on display. It's so horrible.
Yeah.
And back then, like, in Energinet in Denmark, they built this huge in glass.
Yeah.
Everyone was sitting in these small glass cages, and it was so funny walking around down there because no one, it seemed like management couldn't see what they have done. I felt like no one wants to sit there.
No.
But
exactly.
yeah. Okay, so nice.
Yeah. So that's it for transparent wood.
Yeah, it's amazing. It's really amazing to see what all of this is taking us. Also because this is not an area of expertise of, well, neither your or mine. So that's always intriguing to hear about.
Yeah.
So actually, what I've prepared for today is a bit different. But this is triggered by you quizzing me last time about the largest wooden structures in the world built in timber.
Yeah.
So on that, I thought, okay, I think an interesting question could of course be, do you know then what is the largest tree in the world? And large could mean many things. It could be the tallest, but volume-wise, you probably know.
Do I?
Yeah, probably. It's also the name of a very...
Is it a species?
Yeah.
Okay, sequoia.
Yeah, exactly. And then there's one specific of that's very known, which is called General Sherman in California, close to San Francisco. And I've actually I've visited that tree, and it's so huge. It's So it's in an elevation of 2,000 meters, so it's also high. So actually, when you visit it, you are high above, and you go down, and you get warnings. America.
Do you have anything in that area that is 2,000 meters high?
Yeah, because you have Yosemite. It's close to Yosemite.
Okay.
Yeah, so you have mountains there. I can't remember the name of the mountains in that area. But you have to walk down to the tree, and then America. There's a lot of warnings. Don't go down here if you can't walk or you're about to die. So it's fun, but it is hard to walk in because you're in so much elevation.
I thought it was because you had to read so many signs.
Yeah, that's also hard. Walking and reading, it's not easy. But actually, it's just we'll come back to my question soon. Also, it's 84 meters high. It has a diameter of 11 meters.
What?
Yeah, it's so crazy. And the volume of it, that's almost 1,500 cubic meters.
That's crazy.
Yeah, because like one tree is almost like one stand in Denmark, and this is also something we'll go.
What's the age of this?
That's a good question. It's not exactly known because it's hard to know exactly about trees before you
just cut it down.
Yeah, exactly. But it's believed to be dated between 300 to 700 BC. So like it's it's more than 2,000 years old.
Yeah.
But let's keep that in mind because this might return because I have another quiz because you won't guess how old the oldest trees are. So let's take that another time because this is actually not what I wanted to get at.
Okay.
And this is all impressive, but that got me to thinking, do you know how tall the smallest tree in the world is?
How tall the smallest tree in
Yeah.
the world is.
And it's a species, it's not an actual individual tree. I don't think you would.
Okay.
Yeah.
No.
What's your guess?
I have no idea.
Is it in meters?
No. So you're asking about the height?
Yeah, only the
okay,
height,
okay.
not the age or anything, just the height of it.
Okay. Yeah, but wouldn't it then be is it called a bush?
No, that has nothing to do with the definition of a tree, apparently.
Okay. I would say, I don't know. I'll go crazy. Half a meter.
That's really crazy. So I'll give you the answer now.
Okay.
It's what's called the dwarf willow, and it reaches a height of 1 to 6 centimeters.
Okay.
So it's like this is the largest of them.
Wow.
Yeah.
Well, and how is that a tree?
That's and we probably should
What's
look
the
into it because what is the
What's the
definition of a tree?
definition of tree,
Because
yeah.
it could be like a small. It's not even a bush down here.
I have grass higher than that.
Yeah,
at
exactly.
all.
And it's I just thought that was really funny to find out what is actually the smallest tree.
Yeah. Yeah, we might expose ourselves to
Again.
pretty visible that we don't know nothing about that sort of thing. But that also what makes it funny. Okay, that's that's a very small tree.
Yeah.
Okay, one more thing. That's also coming back to the last week's episode, because when I mentioned cross-laminated timber, you were asking about those beams in like sports arenas and so on.
Yeah.
It's actually called glulam.
Okay.
And the difference between cross-laminated timber and glulam is the way that the tree is ordered when it's glued.
Okay.
So here in glulam you sort of glue the panels or the wood product together in parallel instead of being crossed.
Oh, that's the cross.
Yeah, exactly.
Okay.
And it's making it perfect for beams and arches and stuff like that.
Okay.
Because that's
because that's where
the
the
structure
pressure is
where
down on
the
it.
strength is needed. And the this form of construction is quite good. It actually has a strength to weight ratio comparable to steel.
Yeah.
So that's why you see it in a lot of places where the pressure is actually quite high on them. So that's glulam.
Okay.
Now you know that.
Okay.
Or now we both know it.
I've also been told that, I don't know if this is correct, but from a construction point of view, there's, in houses and so, it's a good idea to use timber for these cross, what's it called?
I don't know what they're called, but I know what you mean.
Yeah, cross, probably should put a word on it so people can...
In Danish, it's called rem, maybe.
Yeah.
Or spær.
Yeah, exactly. But that's also for fire, because a really thick wooden
Beam?
Yeah, it's called a beam, of course. It takes much more time to burn.
Yeah.
And the thing with metal is that when it gets hot, it bends.
Yeah.
So actually, it gives more structural integrity under fire. I have been told that. I don't know anything about it, but that's what I've heard.
It's definitely not called a strap.
That's something else.
But let's call it a beam.
A beam, yeah.
Yeah, it's probably the right word.
Yeah.
Awesome.
Yeah.
Do you have any...
No, I think we should probably get into the big one.
Yeah, so the idea with the podcast moving forward is we'll try to do some short, funny sort of news to begin with, and then deep dive on something.
Yeah.
And for this week's deep dive, we have actually turned our attention towards the topic that we discussed in the Lost Tapes.
Yeah, the Lost Tapes, yeah.
Yeah, and that's we discussed robots, in particular planting robots.
Yeah.
And one particular one.
Yeah, one specific one, yeah.
Yeah, which was a Swedish robot called BraSatt.
BraSatt.
I don't know if that's pronounced correctly, but
Me neither.
now it's officially been named BraSatt.
Yeah.
From us.
From us, yeah.
Yeah.
Yeah, and
I don't know.
it's,
Do you want to kick off or?
Yeah, maybe we should just mention that it's a Swedish forestry cooperative Södra who's developing it. And the idea with the robot is to you have an area where you want some plants planted, and instead of you having to go around manually and do it with a shovel and so on, you load the seedlings into this robot, and then you form like a pattern it should follow, and it will drive around plant these things.
Yeah.
So generally speaking, it's an automation of the planting process, which probably makes a lot of sense. So that's the general idea. And then the idea of this project was to bring on, so I took a deep dive on how many are actually involved in building this, which from a technical point of view, how many companies?
So companies, okay.
Yeah, which from a technical and, product point of view is interesting because we have built these kind of products ourselves and we know how hard this is.
Yep.
You actually read this for me the last time because it's a funny thing, but maybe I should take it this time.
Yeah.
So there's a design company on board of this, which is called Boyd, and you can also see the videos of it. It's you have these cartoon videos or what it's called of it, which looks very nice, and you can
animated videos.
Yeah, exactly, animated videos. And it's stated here in the article, our design philosophy was that the machine should convey the same calm and confidence as a colleague in the field. Predictability is crucial when it comes to automation. Therefore, the machine has a calm and responsive design language, while its diagonal cuts give a clear direction. We have ensured that the operator can easily guide and plan the robot's work with a route planner and an intuitive interface, creating a reliable companion in the forest, says David Lamb, creative director at Boyd.
Yeah, exactly. Yeah. And we laughed a bit about that.
Yeah, we did.
Yeah.
But
actually, because I also read this article last time.
Yeah.
Now, yesterday I found another article because leading up to this podcast, we were talking about, of course, we wanna deep dive on this robot.
Yeah.
And yesterday we were talking about the main benefit of these robots, and we could discuss some of the concerns and things that you need to consider, going down this path in a bit. But that was actually, automating, let's say, a workflow that is quite, it's quite hard and time consuming to plant trees with a shovel, and also of course you could also plant with a machine behind a tractor, but of course that you need an environment where you can do that. Otherwise you'll have to, I think at least, of course we're not the experts, you'll have to have a man with a shovel and a bag, and I've tried this, it's quite hard.
Yeah, you can, exactly. You know how it goes.
And so we talked about that being the main sort of driver in order to do this. And also if you read the article, it's basically a cobot because it's also relying on people. So a cobot means that it is an autonomous robot which can do things on its own, but it also needs an operator in order to serve it and help it. And because robots can get stuck, they can. A lot of things can go wrong with robots.
And it has a finite amount of seedlings in it and so on, so you need to load it and
exactly. But I think I found some more articles. I think, and of course we're not the experts, so that's probably why we missed this to begin with. I think some of the other main benefits with going down this path is the succession rate when you plant seeds or trees. I think that is actually quite important because I found in this article, it's actually from Södra. So Södra's current rate of seedling survival is 70 to 75%, meaning that only 3 or 4 seedlings survive longer than 3 years.
Yeah.
I think also coming back to some article we found 5 years ago when we started going into this, I think it's actually quite a important factor, this survival rate. because it is quite an issue if that isn't high.
Then you're just wasting life, you could say.
Exactly. And I think so what this machine also does is it's what is the English word? Scarify the earth in a new innovative way that is better than when people prepare the earth in terms of or the soil.
The soil, yeah.
In terms of creating the best environment for the seedling. So I think that's actually one other important factor of robots like this.
But typically when you deploy robots, it's about getting consistency.
Yeah.
So, yeah, again, no expert, but that would mean if from my, chair here, that would mean that you have to somehow have sensory input on what does it mean to have the correct preparation of the soil. So that would be something about how far down you go, the humidity of it, and so on.
Yeah. Let me just jump to something else then, because it will actually sort of go down that path. But I think also before we end, we also need to talk about just looking at workflow optimization from an atomic point of view, because it's not that. So the reality is that it's actually seen from a business case point of view, it's actually quite worse than you think. Right? We know that. Yeah. But let me just jump into another article, because last time I also mentioned the drone company. I couldn't remember the name of the drone company at that point in time, and the drone company, which sort of got us interested in forestry in general and so on, was called BioCarbon Engineering. Remember?
Yeah, I remember.
So BioCarbon Engineering, I'll just read out, is they don't exist in this format anymore, but I found some let's say intro text from that given time.
Yeah.
So biocarbon engineering will enable global scale ecosystem restoration by planting at least 1 billion trees each year with drones. And then I found a video. It's probably a longer video, but it was sort of boiled down to the essentials. And so the pods that this drone fires off, it's a biodegradable and nutrient-rich pods. So everything is contained in a pod, and this drone just hammers those down in the earth,
them down to the earth
from a couple of meters, flying above the earth. And I also remember the articles and also the guy talking in this video. Of course, I mean, now it probably isn't as weird, and it's probably more like understandable now, but he was talking about it's driven by AI, so it I know you laugh. Driven by AI, so it gets fires precisely at the right depth, at the right location, and they also start by mapping out the area, figuring out where are the survival rates highest for the pods. So that's exactly what you also are talking about with the BraSatt. So the idea with this at the point in time was 100,000 trees a day, and they were building an army of 10,000 drones.
Okay.
Which,
an army.
That's the word. And they were, aiming for 1 billion trees a year. I have no idea how that math adds up, but
do they mention anything about survivability?
No, not really. At least not what I found.
Yeah, because I think planting trees just as a number, it's probably like installing wind turbines.
Yeah.
As a number of megawatts you can produce. But if they actually don't produce anything, then what's the point? And if you just plant 1 million trees and 10% lives?
Yeah, 1 billion.
Yeah, 1 billion. But 10% lives, then...
Exactly.
Yeah, but I can remember these drones, and I can also see that they can go places where you can't get machine out, you can maybe even get people out there.
Yeah, exactly. And to be honest, then I stumbled on a lot of other things on YouTube sort of related to this, and I think we should probably do another episode just on this, because this is actually quite interesting.
Yeah.
But I think the company is now bought by a company called Dendra, and they still have this aerial seeding.
Yeah.
So maybe we should do a deep dive on that.
How far are they on the army?
They have, I don't know how to, they have maybe just turned the volume down a bit.
My best guess, max of 3 machines.
Maybe.
Yeah, okay.
Maybe.
But yeah.
So workforce optimization, no, not workflow optimization. Maybe we have a couple of minutes left. Maybe you just add in some knowledge and experience from when we did robot together with a Danish company called Nilfisk, which does robotics on, it's a cleaning robotics for large areas.
Yeah, so what you're asking for is workflow optimization, or what is it more specifically?
Yeah, so it's all, I remember when we did that, in the beginning you have business cases that illustrates, extreme high gains in terms of, potential new business, and you'll reduce, labor by this and this and this.
Yeah.
But the reality is, and you know a lot about this, robots in real life scenarios, the complications, the manufacturing issues, maybe you can just share a few details on this.
Yeah, and actually the thing is, we've always been warned about, robots will take over our jobs, and at some point we won't have any jobs. Reality is that hasn't happened, and it probably won't. What robots do is they take care of, you call it the dangerous, it's the 3Ds, I can't remember one of them. It's dangerous and dirty and let's call them non-desirable jobs. So that's what's actually happened, is that they automate the things that, robots are good at.
Yeah.
And there's this, the wet dreams of all the commercial guys is that they can sell this robot that can just do everything. Reality is that it's extremely hard to build autonomous systems.
Yep.
And you can probably build one like a prototype.
Yeah.
But going from prototype...
Yeah, that works in one environment.
Yeah, that works in one environment. And going from that into production is way harder. So it's a really extremely hard.
Exactly. And
there are so many subsystems in robots, and so many considerations, because everything is also, there are legal things around them, so much things that you need to take care of. And I can see from this robot alone that can never be safety approved. Probably not. Then they have to drive like and say a lot of sounds.
Yeah, try to add some words on why do you think that's the case.
Yeah, and that's actually easy when you know a little bit about robots. Is that so? What essentially is needed, you need it to be safe, and to have a safe system, you need to use. You need to get it safety approved.
Yep.
And that is done by a third party. And that third party needs to follow regulations on how to safety approve. So a way of getting through such a process is to use safety graded, sensors and so on.
Yeah.
And as I can see here, they have a LiDAR, which is a Velodyne LiDAR, which is a 3D LiDAR, and just that in itself is extremely expensive. So the robot has to be expensive. And then they have a 3D camera, which is a set, which is not safety approved either. So just by looking at it, I can see they have no safety approved, sensors. So going through the process of getting this machine safety approved is going to be a hell, and it's not going to work. And so, of course, you can get around this, but this just illustrates to me that this machine that I see before me is in fact a prototype.
Yeah.
But I will say this, kudos to, they have actually built one of these.
Yeah, it's a mechanical working prototype.
Yeah, it looks like that.
Videos and all kinds of...
I will say that when I look at the videos, though, I never see the robot and the planting in one picture. So I might be a little concerned that that's the marketing. of it.
Yeah.
So,
yeah,
but I think everything starts somewhere, and it's nice to see that someone is going the extra mile to try to do something.
exactly.
Best guess is that this is still years out in the future before this is actually a thing.
Yeah,
And you still also have to prove that this actually increases the likelihood of the seedlings living.
yeah.
Because what if it has nothing to do with the planting, but actually the animals coming in there and eating them?
Yeah.
For example, it's a complex thing to answer.
Exactly. But now that you mentioned this, because that's also why you need to allow technology and research and all that kind of stuff. Because sometimes, starting a project like this, where the aim is to create an autonomous planting machine, there could be side effects where you develop technologies which is, extremely useful in other scenarios, and maybe this new way of scarifying the earth, maybe that has potential in some other, let's say, setup or environment. So I think that's actually quite nice.
Yeah, and again, the expertise from me and also from you comes from robotics. There can be something in here that we don't see because it's so specific for forestry.
Yeah.
I'm just looking at it from a technical point of view and seeing, oh, Jesus Christ, this is going to be hard.
Yeah.
And again, if you go from a prototype to production, and as well as me, a lot of people can put writing on that. That's probably much worse than just building the prototype.
Yeah, prototype is easy.
Yeah, but it would be nice if they could give like a price point for this.
Yep.
My guess is it's high.
Yeah, exactly.
And also, just again, because from technical angle, as I also said in the beginning, I also took a bit of a deep dive into, so how many partners are there actually for building this? Mm-hmm. This is also a good indicator if it's a prototype, because again, if we go back to, having a actually commercial viable product, you have to have it safety approved. Yeah. And someone has to take the responsibility of safety approving. And if you have like 10 partners building something, you don't want to be the partner that has that job. So I can see here it's at least
1, 2, 3, 4, 5, 6, 7, 8, 9.
Yeah, and you have Södra themselves. Then you have Chalmers, which is a university. You have Chalmers.
Chalmers, is that a university?
Yeah, that's a university in Stockholm, as far as I remember.
Okay.
And you have Chalmers in Industry Technique, which is probably they are definitely most likely, is a, what's it called? Can you remember the Danish word for it now?
Then it's hard.
Yeah, then it's really hard. Consultancy on something. And you have BidAddict, which is also that's a consultancy in software. You have Excellent Engineering, which is a consultancy in mechanical engineering. Then you have Blue Engineering, which is an automation consultancy company. So you have a lot of consultancy companies into a project, and consultancy companies typically don't, some might, but typically don't want to take the responsibility of the whole legal process. So it's just from that. I also have Excellent Engineering. Or maybe I actually did mention those. So just from the setup of it, I can see that there's a long way before it's a commercial viable product. But they don't say it is, but some of the videos might give you the idea that it is.
Yeah.
But really interesting, and let's see where it goes.
Interesting.
Maybe back to our Nilfisk days. You also visited these fairs. Mm-hmm. Interclean in Amsterdam and so on.
Yeah.
And every year they have like a new cleaning robot on display. Yeah. Very few of those actually.
You never see a commercial daylight.
Yeah, exactly. So.
Yeah, it just takes.
Yeah, it's hard.
Yeah.
But cool.
Exactly.
Yeah.
So, We'll probably get back to this topic because
definitely.
It is robots in now forestry is something that is dear to our heart. So I mean, of course, robots has a role, especially also considering. So Danish forestry is not really remote because the forests are small and they're close to towns.
Yeah.
But if you go to, like, let's say Sweden or Canada or other countries, of course, I mean, it's much more remote. So you need some kind of, robotics and technology that support this environment. So of course it will be a thing.
Yeah, most definitely. And probably, as I see it, I could be wrong, but the first thing you would automate was the machines cutting down the trees, and not so much the planting, maybe.
Yeah, then you should definitely be concerned about safety.
Yeah. yeah, exactly. But that probably, that just makes sense to me because you already have this really expensive equipment in the forest. So automating that would.
I've actually seen. I can't remember which company it was, but that there is, and I don't know how sort of commercialized it is yet, but there is a company that sort of support this remote steering where you have an operator sitting in a, let's say, what's that called, a simulator.
Yeah.
That actually controls the.
And then again, that makes total sense if you have these remote regions in Sweden or everywhere else where there's far away to go.
Yeah.
It makes sense that he could, instead of having to drive out to the forest and back every day, it could take like hours each direction.
Yeah.
You can just sit home and do it. That makes sense. There you just need a really good comm link, so you don't have too much delay.
Exactly.
Believe me, delay is not something you want in a feedback system. So
no,
it can go terribly wrong.
Yeah.
But I think maybe we should. There's so many things on this, and I found some really nice, ideas. This article
it's old.
No, it looks old, but it's actually, as far as I remember, not that old. It's from 2021.
Oh, there's a cloud.
Then
it's new.
Yeah, but I don't know why the pictures are so.
But this, of course, you can't see this. But there's, what's the name of this robot? Because it looks.
Yeah, it's like on legs. Timberjack walking forest house that source.
Wow.
I best guess is that this is not really a thing either. But look at this. This is also something you remember when we looked into forestry the first time.
Yep.
Can you remember this?
This is a nice article. Oh, yes. Oh, that's awesome.
Yeah.
Try to explain what that is.
Yeah. So this is
I totally forgot this one.
This is essentially a research project, right? Where you like so one of the most expensive things are the big machines that you send into the forest to cut down the trees. And this thing was the idea that you could create a robot that has essentially two hands, which is suspended in like two arms and then connected together. And then it could crawl from tree to tree and then fell them.
Yeah.
Like that. And it's small, and of course it has a predefined reach somehow. And then you didn't need those big machines. I don't think it ever made it out there. This is it's from 2015, but they of course also made these how's it called?
I have no idea what.
No, exactly, because this is now it goes crazy, right? Because this robot
has 4 arms.
It has now 4 arms, and it defies gravity completely. Which is always nice if you have to do robots. If you can just ignore gravity, that would be nice.
Yeah.
So maybe we should look also into all the other. There are so many things happening because, there could also be one of the. This is an autonomous. What is it called? It's called Conrad Pulley. Takes logs from a steep terrain house down to the roadside.
Yeah, so it's like what's that called in English?
It's called a pulley, I think, but
it's the machine that extracts the timber from the forest.
Yeah. But as you know, all of these are prototypes, which are in this article.
Forwarder.
But this is also then they go completely balalaika here, Then now they've automated the entire thing.
Yeah, it's like this, the factory.
In a picture, which is always easy.
Yeah.
But that's kind of some of the ideas, and I think we should have maybe even a special on just robotics. Yeah. But yeah, there are a lot of cool stuff going on. Although it seems like from this article, which is from 2021, but they look backwards, and it seems like most of these projects has just stopped.
Yeah.
Probably.
But it's interesting.
Yeah, it's interesting.
And
also,
funny.
And also like for nerds, it's
for tech-savvy guys like us. It's awesome.
That was a really fine word for reading. Nerds. Tech-savvy guys.
Yeah.
Yeah,
exactly. Okay, but I think now time is up, so we probably just start compiling news for next week's episode.
Yeah, let's do that. I have some interesting quizzes ready already.
Oh, nice. Great, but let's say goodbye from now, and we'll catch each other in the next episode.
Yeah, see you next week.
Bye-bye.
Well, hear you.